All right, so yeah, hope you're all doing well today. This is actually our last trig unit, trig lesson. And your aim for today is practice solving trigonometric equations, which, we're going to go through a series of questions that we've seen before. So either on the classwork or the homework. Do now is, I think this was from the first or second lesson on this trig equation unit series. But yeah, just try solving that, and then we'll reconvene in like a couple minutes. But yeah, the homework, by the way, it's just 3 application questions. It's has to do with physics formulas that you'll see. One of them is actually a Dant harmonic motion, which we've seen before. But yeah, just 3 trig equation physics questions for the homework. Not really what we've been doing in the past few days, but yes, just something else you can see with this type of problem. Okay, but yeah, just try this problem on your own. Take another minute, and then we'll reconvene. Okay, so I do want to give everyone time to work on the classwork today. So I'm just going to go ahead and go over the do now solution. I'm going to scroll up for that. Okay, so yeah, as I said, this is a problem we've solved before. We're first going to square both sides. We're going to get cosine squared x plus 2 cosine x plus 1 on the left, and then sine squared x on the right. Okay, but just remember that, since we're squaring both sides, we do have to check for extraneous solutions, okay? Because squaring both sides is something called an irreversible operation. Another example of that would be like dividing by 0 or multiplying by 0, in which case we have to check for the solution that we actually get at the end, okay? So, but yeah, on the right-hand side in the next step, I change sine squared x to 1 minus cosine squared x. And then from there, you just combine all the terms. I add cosine squared x to both sides. You get 2 cosine squared x. And then you have your 2 cosine x there. And then you subtract 1 from both sides, you get 0. Okay. A bit, actually. From there, you can factor 2 cosine x from both these terms. So you get 2 cosine x times cosine x plus 1 is 0. And there you have 2 factors. Okay, so on the left, you get 2 cosine x is 0. On the right, you get cosine x plus 1 equals 0. For this equation, you can divide both sides by 2, you get cosine x is 0. And then from there, you should realize that the angles in question should be pi over 2, which is 90 degrees, and 3 pi over 2, which is 270. And for the other equation, cosine x is negative 1, there you should realize that the angle is pi, or 180 degrees, as you see from my diagram here. All right. But yeah, as I said, because, we squared both sides in the first step, we had to check for extraneous solutions. So I'm going to check for each of these this time. So first is pi over 2. As you'll see, you're going to get cosine pi over 2 plus 1 and sine pi over 2 on the right. Cosine pi over 2 is 0, so we get 0 plus 1 is 1, so that works. So pi over 2 is a valid solution. Next, we have 3 pi over 2, and then we get 0 plus 1, right, because cosine 3 pi over 2 is 0. Sine 3 pi over 2 though is negative 1, right? So we're going to get 1 is equal to negative 1, which is a false equation, which means that 3 pi over 2 is extraneous. And then lastly, we have cosine of pi plus 1 and sine pi on the right. Cosine pi is negative 1, sine pi is 0. So we get 0 equals 0, which is true. So pi is also a valid solution here. So in sum, we have pi over 2 and pi as our final answer. All right, but yeah, I'll give you a sec to copy that, and then after that, it's just the classwork worksheet. So 4 problems. We might not be able to get to all of them today, but I'll upload the lesson plan with the solutions on Google Classroom in case you want to take a look at that. All right. Did anyone still need to copy this? No? Okay. All right. I'm going to move on then. So yeah, as I said, I just want you to work on classwork now. It's on Google Classroom, but you can also just refer to what I'm showing on the screen here, right? Like you have questions 1 and 2 here. There's 4 questions in total though, so if you finish these early, feel free to go on to the latter 2 questions. But yeah, let me give you all, so we have until 150. Let's say until 140. So I know that that's not too much time, but I do want to go over the solution. So that's like 5-6 minutes. Yeah. And then if you feel comfortable, feel free to upload your solutions to Google Classroom, and then if you want, you can present the work. Okay. Again, that's a plug for recommendations. If you are planning to ask me for recommendation, you should be participating a lot in class, among other things, but yeah, that's one of the key components. All right. But yeah, I'll see you all in 5 minutes. Okay. Yeah. Sam, go ahead.
Okay, first what I did was convert cosine squared of x into 1 minus sine squared of x. So that would leave us with the equation below. After that, I moved everything to the left-hand side, which would get us the next equation. And then I factored it into the 2 parts over there. After that, I made each part of the equation equal to 0 because of the 0 product property, which would get us sine of x is equal to half and sine of x is equal to -1, which could then be converted to pi over 6 and 5 pi over 6. And for the next one, -1, sine of x equal to -1 is equal to 3 pi over 2.
Good. And then there's one more step, right, for the solution set, because we're solving over R, right? Yeah. Yeah. Do you want to say that?
I didn't really do that in my work.
Oh, okay. Okay. That's okay. But yeah, just remember you have to add 2k pi to these, because we're solving for all real solutions. So yeah, just write plus 2k pi after all these angles. And there's actually a way to simplify this. So does anyone see that? Like how to write these 3 equations as one equation, or one expression, I should say. So like as a hint, notice the difference, like how far apart they are. Like for example, like 30 degrees to 150, right? They're 120 degrees apart. And then from 150 to 270, which is 3 pi over 2, that's also 120 degrees apart. Right. So technically, you could summarize this. This can be summarized as pi over 6, right, which is 30 degrees. Yeah, this can be summarized as pi over 6 plus 2k pi over 3, right? Because 2k pi over 3, 2 pi over 3 is 120 degrees. Yeah. Does someone have a question? So someone raised their hand.
I raised my hand because I thought it was like plus 4 pi over 6.
Oh, yeah, a 4 pi over 6 is also, that'll be the same thing, right? Yeah. But just, yeah, you can simplify it to 2k pi over 3, but yeah, that's fine. But yeah, not that you have to do this, it's just, that's, it comes up if you have a multiple angle like 3x instead of x here, like that could be useful. Anyways, let me move this up step. All right, anyone want to go over 2? 2 is also a classwork question that we've done before. But yeah, here are the final answers here. Does anyone want to walk us through it? I have the solution here, so just tell us the logic behind each step.
I don't know. I thought it was like a one-step question. Uh, uh, where I just put the equation into two factors. 3 cosine x minus 1 times cosine x minus 4. I did this because the a value is 3. So I just started with that for the first part, which made me write down 3 cosine of x minus 1, because I used -1 because I knew that the last value 4 had to be both negative numbers, and the smallest value had to be on the left hand side of the equation, which is -1. So -1 times -4 is equal to 4, and I don't know, I just multiplied 3 cosine x minus 1 times cosine x minus 4.
Okay, good. Yeah, so yeah, you can factor it like through that method. And the way I did it in class before was like the AC method. But yeah, like you can split -13 cosine x into -12 cosine x minus cosine x, right? And then factor by grouping, right? If you're wondering how I got that, that's like the AC method. So as Sam mentioned, like the quadratic coefficient is 3 here. So you do 3 times 4, which is 12. And you think of two numbers that multiply to 12 that add to -13. That would be -12 and -1. Okay, from there you can factor by grouping, and then you get this. And then you get cosine x equals 1/3 from this factor, and then cosine x equals 4 from the right factor. Cosine x equals 4, there's no solution, right? Because the max value of cosine is 1 without a transformation. For the other equation, you get x is arc cosine of 1/3, and then use your calculator. In radians, it's 1.23096 radians. And then the other answer is in quadrant 4, since cosine's positive in quadrants 1 and 4. So it'll be 2 pi minus that angle, which is 5.05223. Okay. So these will be your final answers for question 2. All right. But yeah, does anyone still need to copy this? Otherwise, I'll move on to question 3. Okay, so wait, just let me know when you're done. Okay, has anyone still need it? All right, if not, then I'll move on to question 3. And from there, we'll close. Question 3, we had sine 2x equals 2 tan 2x. We're going to solve on R. So I'm going to change tan 2x to sine 2x over cosine 2x, right? Because tangent is sine over cosine. Don't be thrown off by the 2x. You can still do this, right? So like tangent of whatever angle, you can split that up into the sine of that angle divided by the cosine of the angle. Okay. From there, I multiply both sides by cosine 2x. You get sine 2x cosine 2x equals 2 sine 2x. And then I'm gonna subtract this expression from both sides. You get 2 sine 2x minus sine 2x cosine 2x. And then from there, I'm going to factor the GCF, the greatest common factor of sine 2x from both these terms. You get sine 2x times 2 minus cosine 2x. And there you get two factors, right? So sine 2x is 0, and 2 minus cosine 2x is 0. Now, from this equation, there's no solution, right? Since the cosine of any angle can't be more than 1, right? So don't be thrown off by this 2 here. This 2 is not affecting the amplitude, right? In order to affect the amplitude, you would have to write the 2 here, right? But that's not what we have here. So yeah, cosine of any angle, like cosine of 2 times an angle, doesn't matter, right? Max it could be is 1, okay? So yeah, from there we get no solution. From the other one, sine 2x is 0. I use u substitution, so I let theta equal 2x. From there, you can write sine theta is 0. And then at that point, you realize that the possible angles, as from this diagram here, right, it's 0, pi, 2 pi, right? All those angles would make sine 0, right? So 0, pi, 2 pi. That can be summarized as k pi, right? Where k is an integer, right? So from there, you can substitute back 2x for theta. You get, 2x equals k pi. So x equals k pi divided by 2. Okay. So here's your final answer. X equals k pi divided by 2, where k is an element of z. All right, but yeah, while you finish copying that, let me just close with announcements. First, there is SGI as always at 2:47. Secondly, the next quiz is on Friday, so that's in 2 days. So please study for that. I did post a practice assignment on Alex, so please try that if you haven't already. It's good review for the quiz. You'll also get used to the Alex interface. But that assignment, the practice assignment, is like 10 questions, I think it was, and then the actual quiz is 6 questions. Okay. All right. But yeah, if you have questions or comments, you're free to stay to ask me. But if not, you're free to go, and I will see you all tomorrow. All right. Take care.
Have a nice day.
Have a
All
nice
right.
day.
Thank you, you too.